vertical measuring lines. The problem with the perspective, unlike an elevation, is that nothing is to scale. It's in scale from a perspective point of view. It looks just like whatever you'd see if you were looking at it. However, it's not to scale like an elevation would be. And what does that mean? Well, I don't have my elevation out, but does everybody remember what this height was right here? Does anybody even remotely remember 20-something feet?
Sure.
Let's call it 20 feet. Let's say we know that's 20 feet. Well, if I take my scale and I go to measure it, oh, son of a bitch, it's exactly 20 feet. That's not good. Sorry, I'm not supposed to swear on the video. Here, let's use the wrong scale. Yeah, we'll use that. All right, well, here when I measure it at 3/30 seconds, it's almost exactly 20 feet. That's great. When I measure it up front, it's 23 feet. When I measure it in the back, it's 16 feet. In perspective, vertical lines that are closer to you look bigger than far away. And that's just kind of common sense. You get that. Classic perspective. Railroad tracks going off into the distance. Okay. Let's say that's a 10-foot light. That's also a 10-foot light. That's also a 10-foot light. But as you can see, they get shorter. But here's the horizon line. And if you'll notice, the proportion above and below the horizon line is the same. Half of the poles above it, half of the poles below it. In this case, let's assume I've got a 5-foot high eye height. That's one way that we can track proportion. This is a 1-point perspective. Ours are usually 2-point. They get a little more confusing than that. But what that tells me is, if I know any one distance in the drawing, I can then find out that same distance any place else. How do I do that? If I know that this wall is 20 feet and I divide this into 20 equal sections, each one of them is going to be a foot. If I divide it into 10 equal sections, each one of them is going to be 2 feet. Well, I could take my scale and measure it and say, okay, I might be able to see it, but that line is 16.5 feet at 1/8 inch scale. Well, if I divided 16.5 by 20, I don't have my calculator on me, but I had to say it's probably about 0.82 something feet equals a foot. So I could then go through and measure 0.82 feet, which is scary. I mean, I don't want to go through all that trouble. There's an easier way. If I start at the bottom, trace, Okay. I'm going to start at the bottom of the line. I'm going to end at the top of the line. At the top of the line, I'm just going to put a light line right across. Yeah, you can see that good. Here's the bottom of the line. I'm then going to take my scale, and it doesn't matter which scale you use. Put the 0 on the bottom, spin the scale till the height shows on the scale. So in this case, that's 20, but I want to do something a little smaller. So let me do 3/16. Here we go. Okay. Now, I put the 0 where 0 is. I put the 20 where I know the height of the wall is. And I'm going to put a mark every 2 feet. 1, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 28, 30, 32. Just going to darken up that horizon line. Okay, now that I put those little marks along that angled line, if I go straight across with my parallel bar, two foot, 4 foot, 6 foot, 8 foot, 10 foot, 12 foot, 14, 16, 18, 20. In addition, 2, 4, 6, 8, 10, there's 20, 22, 24, 26, 28, 30, 32. If you'll notice, the horizon line crosses between 30 and 32, which tells me that the viewpoint for this is about 31 feet up in the air. If I know the height of any item, I can set up a measuring line like this. If I know the height of the horizon line, if I knew that it was 31 feet in the air, then I can find the height on any single item here. What's the height to the top of that window? Draw a line down to the ground. There's your 0. There's your horizon line. Put any scale on there that gets me to 31. Sure, I'll use 1/8" scale. There's 0, there's 31. Right, and hang on, let me just draw a window across from the line here. Do a straight line here. There's 0 feet at the base of the house. I spin my scale up till 31 hits the horizon line. There's 31. The top of that window is about 28 feet. Because if I put this at 0 and I put that at 31, all I have to do is see where that, I could mark off, I could do the same thing I did before. I could go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. There's 28. And I could draw straight lines across, and I would see 26, 24, 22, so we're probably a little off with that 20-foot dimension, but that says that window's about 6 feet tall, where in reality it's 4'9", but we probably, that might not have been exactly 20. These come in real handy whenever you have to subdivide any straight line into a bunch of different lines. So these I use a lot. That's the vertical measuring line. It is in here. I do walk you through it in the handout, and I give it to you step by step. The next pointer is horizontal measuring lines. I'll be honest with you, I don't use these very often, so I'm not going to terrorize you with this. If you're bored, go through it, figure out what I've done. It winds up setting a horizontal measuring point off to the horizon line, and then you can subdivide it in a similar way. The reason I never use that is because I then go on to, and I'm going to skip ahead of circles in perspective, I just use dividing boxes. All right, so for example, if we know that this building's 20 feet tall, we know that that wall's 20 feet, and I got to build something that's 6 feet over going along the wall, well, I can't measure this wall 6 feet. I don't even know how long that wall is. But if we assumed, now I'm sad I don't have the assignment up, but here, I'm going to look for it. Let me just get the dimensions of that house. Site drawing. Oh, that's not what I wanted. Okay, so the house is 25'3". So if I know that the house is 25'3" wide, well, I know that's half. Here's half by putting that cross there. Wherever it crosses, there's half. So I know that's about 12'6", and that's about 12'6". And if I then do the same thing all over again, and make crosses and cut the halves in half, I know that's 12'6", that's got to be about 6'3". So that's pretty close to 6 foot. And close enough usually works in perspective. I mean, when you start getting to where you're dealing with inches in a perspective drawing, realize the thickness of your pen or your pencil is a couple inches. So using the dividing boxes, which we used earlier on, is a great technique. And where you're going to see it make a difference, because if you try and guess where the center is on a perspective, you're usually wrong. I mean, looking at this wall, which has got a little more distortion to it, because the angle we're looking at, it slopes back more than this one. You know, where is the middle? Is it here? Is it here? Is it here? I don't know. And I know that the back half is going to be a little shorter than the front half visually. So I can't just measure it and say, okay, that's 12, there's 6, that should be the middle. If I broke that line into equal parts, measuring-wise, that's where the middle would be, right here. But if I do it with the scale, you can see it's a little further back than that, and it's enough to make a difference. You would notice that, and especially the more it distorts from where you're looking at it, if it's over on one side or the other, the more the shape looks like this, or like this, as opposed to a rectangle, the worse off it's going to be. For example, if you were looking at an angle where the side of the building looked this severe, which happens as you get close to the building or close to the object, the center of it is way back here. So the front's a lot bigger visually than the back. And all you're doing is dividing boxes in half. You've also figured out a way to divide it vertically when you put that X in there. But that way, you've got to go back to the vanishing point. And let's talk about vanishing points for a minute. This is a 2-point perspective. That means there's a vanishing point over to the right, and there's a vanishing point over to the left. Here was a 1-point perspective. You're staring right down railroad tracks or a straight road. There's only one vanishing point. This is a 2-point perspective of railroad tracks. It's got a left vanishing point and a right vanishing point. Anything in a perspective that's horizontal goes back to a vanishing point. Anything that's vertical is going to stay vertical. So when you draw your walls, the walls are drawn straight up and down in a 2-point perspective, but the tops and bottoms of them are always going to go back to a point. That point, that vanishing point, is always on the horizon line. Now let's see. Everybody come up for a second. Come on over here. Not that way. If you look out in the distance, let's stand. If you stand and look that way, so kind of come around behind me, we're going to look out over the river, over this building. If I'm looking straight at those trees, off into the distance, where the trees meet the ground is the horizon line. Now, it's actually going to be, because you got a little hill there, the highway's a little higher than the ground, you can kind of see the river. The river's probably about where the true horizon is. Take a look at the edges of this building, the roof. If they're going left to right, if you took your finger and you followed them and just kept going, you're going to see a point that's going to be right over your left shoulder. it's going to be right on the horizon line. If you take a look at the lines in the roof that are going front and back, draw a line, keep staring where you're at, take your finger, go back to the horizon line, it's going to be over here someplace. So those are the two perspective vanishing points. Things that are going, I believe this is east-west, go to that vanishing point. Things that are going north-south, go to that vanishing point. As you turn your head, or change your view, if you turn your body, those vanishing points are going to move. They're going to be wherever your eye is looking straight ahead, look to the left and right, and you'll find those vanishing points. Real world example. Now come on over here, let's look back up on the screen. What we have here, it's easy to find one of them because I can take my triangle, I can trace this and just go back to the horizon line, and what you'll notice any lines on these drawings, any horizontal lines, all go back You notice that? They all go back to that one point on the horizon. That is the left vanishing point. These lines also go back to a point on the horizon. The problem is that point is going to be don't do this on the school desks, please. This is mine, so I can do it. Okay, my guess is that vanishing point on the horizon is going to be somewhere out here by my book bag. If you want to divide stuff in half vertically, with your X's, let's say I want to see what half of this, the front of this building is. I go ahead and make my X. That's the middle of it. Now I have to draw a line in the middle that gets back to the vanishing point, but I can't just set my ruler on it because it's way over there. Go ahead and start spinning it till it looks, can you see, look at the bottom of the windows. Do you think that's going to the same vanishing point as the windows? No. Is that, you know, that's looking pretty close. Also notice there's a line here. That one goes back to that same vanishing point. So if I can kind of guesstimate, it might even be a little off. There's a line that splits that shape into two. So that's the top half, that's the bottom half. And that's the line. Here I've got the luxury of being able to go back to a vanishing point. Bottom half, top half. Here I've got to kind of guesstimate with what I've got. And that's a line from there going around. So using those dividing boxes, and this is why I don't use horizontal measuring lines a lot, because I can always take something and divide it into 2s, 3s, 4s, 6ths, 12ths, not tenths, 8ths. I can get close enough if I do that. If I know something's 4 feet over and the wall's 30 feet long, well, if I can divide the wall into 6s, I know that each one of those is 5 feet, I'll just move it over a little. So that'll give you some basic proportions. So that was dividing boxes. For thirds, I didn't talk about that yet. We talked about dividing. If you have a square, a rectangle or square, and you go point to point, That'll divide it in half. If you go from the top point or the bottom point of the half, and you go down to the corner again, where it hits those lines, where it hits the original lines that you drew, now you just divided it into thirds. So anytime you have a rectangle, and that works for a rectangle, that also works for a rectangle in perspective. I just divided it in half. If I go to that corner and I go up to the halfway point, if I go to the halfway point and down to that corner, where it hits these lines, this is what thirds would look like in perspective. Because of the distortion, because of the shape, that front third looks way bigger than the back 2/3. But that is perspective-wise where the thirds would fall. If you take your thirds and divide them in half, well, now you've got sixths. So, and then if I divide the sixths, if I cut that one again, well, now all of a sudden I've got ninths. And you can carry that on as far as you want to go. All right, so there's a ninth. There was a sixth. So you can divide it and figure it out. Those I use all the time. So dividing boxes I use forever. Constantly. When I'm doing my sketching, I'll do those just to find out where something falls. My last little pointer is on circles. And we had actually discussed this early on in class. If you remember when I told you if you had to freehand a circle, the best way to go about it was draw a square, cut it in half, cut it in half, and do 4 separate arcs. And you can get pretty close to freehanding a relatively accurate circle. Whoa! Okay? You can do the same thing in perspective. If the perspective shape this will make it easier. If you can draw a square in perspective, and I just taught you how to find the halves by doing a cross in a dividing box. And again, we're just going to kind of guess where that is. I think, does that look about right? Yeah, it looks about right. What you're trying to do here in this case, I want the slope of the line to be somewhere between here and here, and you're eyeballing it. Just like I did here, now I draw 4 arcs. I'm going to start off kind of lightly because it's real easy to mess it up. And now what you have is you have an ellipse. It's not a circle, but it's a representation of a circle in perspective. And if it gets severe, depending on the slope of the perspective, is going to result in the shape of the circle. That I use all the time too. So if you can get a square in perspective, then you can put a circle within it.